Hello everyone and welcome back to JCE Connect. I'm Professor Rajendra Jotawar from Jain College of Engineering, and today let's continue the third module of cloud computing, virtualization. Here we have introduction, characteristics of virtualized environments, taxonomy of virtualization and cloud computing, pros and cons of virtualization and technology examples. Starting with the first one, what is virtualization? Well, we all are familiar with a computer or a household computer or day-to-day used computer. That computer has resources like CPU, memory, storage space, network card, video card, etc. All these hardware components work together to run this computer. Well, if you look at your computer right now, I doubt you are using even 10% of your computer's potential. Virtualization allows us to better utilize the resources available in a machine. Now, for a minute, let's take an example of a server machine. Now, this server machine has a lot more resources than any household computer. It has high performance CPU, RAM, storage space, and all the other things. How does this help us? Well, we can take a software and put it on a server machine in order to get multiple machines out of it. The software which we install on this server machine is called hypervisor. Hypervisor is a software that allows us to create multiple virtual machines or virtual machines on a single physical machine. We have the resources of a server machine like high performance CPU, memory, storage space, etc. All of those can be emulated inside a software. We can have a pretend environment or virtual environment where all of this hardware seems to be, and we can create an environment using this software called hypervisor. With this software we can put several virtual machines in a single physical machine. Virtualization technology have gained renewed interest recently due to several phenomena. First one is increased performance and computing capacity. The average end user desktop PC is powerful enough to meet almost all the needs of an everyday computing, with extra capacity that is rarely used. Almost all of these PCs have resources enough to host a virtual machine manager and execute a virtual machine with by far acceptable performance. The same consideration applies on the high-end users of a PC market or a personal computer market, where supercomputers can provide immense computing power that can accommodate the execution of hundreds and thousands of virtual machines. Second one is underutilized hardware and software resources. Hardware and software underutilization occurs due to two main reasons. First one is increased performance and computing capacity, and the second one is the effect of a limited or occasional use of resources. Computers today are so powerful that in most cases only a fraction of the capacity is being used by an application or the system itself. Moreover, if you consider an IT infrastructure of an enterprise, many computers are only partially utilized, whereas they could be utilized without interruption on 24/7 and 365 days basis. For example, desktop PC is mostly devoted to an office automation tasks and used by administrative staff itself, are only used during the working hours, remaining completely unused overnight. Using these resources for other purposes after hours could improve the efficiency of an IT infrastructure. To transparently provide such services, it would be necessary to deploy a completely separate environment which can achieve through virtualization. Next one is lack of space. The continuous need of additional capacity, whether storage or computational power, makes data centers go quickly. Companies such as Google and Microsoft expand the infrastructure by building data centers as large as football fields that are able to host thousands of nodes. Although this is possible for IT giants, in most cases enterprise cannot afford to build another data center to accommodate additional resources capacity. This condition, along with hardware underutilization, has led to the diffusion of a technique called a server consolidation, for which virtualization technologies are fundamental. Next one is greening initiatives. Recently, companies are increasingly looking for the ways to reduce the amount of energy they consume and reduce the carbon footprint. Data centers are one of the major power consumers. They contribute consistently to the impact that company has on the environment. Maintaining a data center operation not only involves keeping the servers on, but a great deal of energy is also consumed in keeping them cool. Infrastructure for cooling has having sufficient impact on carbon footprint of a data center. Hence, reducing the number of servers through server consolidation will definitely reduce the impact of cooling and power consumption of a data center. Virtualization technologies can provide an efficient way of consolidating the servers. Last one is rise of administrative costs. Power consumption and cooling costs have now become higher than the cost of IT equipment itself. Moreover, the increased demand of additional capacity, which translates into more servers in data centers, is also responsible for significant increment of administrative costs. Computers, servers in particular, do not operate all on their own, but they require care and feeding from system administrators. Common system administrators' tasks include hardware monitoring, defective hardware replacement, server setup, updates, server resource monitoring, etc. These are labor intensive operations, and the higher the number of servers they have to be managed, the higher the administrative cost goes. Virtualization can help to reduce the number of required servers for a given workload, thus reducing the cost of administrative personnel. Next one we have is characteristics of virtualization. In a virtualized environment, there are three major components: guest, host, and virtualization layer. The guest represents the system component that interacts with virtualization layer rather than the host as would normally happen. Host represents the original environment where the guest is supposed to be managed, and virtualization layer is responsible for recreating the same or different environment where the guest will operate. There are three major characteristics of virtualization: increased security, managed execution, and portability. Starting the first one, increased security. The ability to control the execution of a guest is completely transparent manner opens a new possibility for delivering a secure controlled execution environment. The virtual machine represents an emulated environment in which guest is executed. All the operations of the guest are generally performed against the virtual machine, which then translates and applies them to the host. This level of indirection allows the virtual machine manager to control and filter the activity of the guest, thus preventing some harmful operations from being performed. Resources exposed by the host can be hidden or simply protected from the guest. Moreover, sensitive information that is contained in a host can be naturally hidden without the need to install complex security policies. Hardware virtualization solutions such as VMware or virtual machineware, desktop, VirtualBox, and Parallels provide the ability to create virtual computer with customized hardware on top of which new operating systems can be installed. By default, the file system exposed by the virtual computer is completely separated from one of the host machine. This becomes the perfect environment for running applications without affecting others in the environment. Next, we have managed execution. Virtualization of execution environment not only allows increased security but wider range of features also can be implemented. In particular, sharing, aggregation, emulation, and isolation are most relevant features. In sharing, virtualization allows the creation of separate computing environments within the same host. In this way, it is possible to fully exploit the capabilities of powerful guests which would be otherwise underutilized. In aggregation, it is not only possible to share a physical resource among several guests, but virtualization also allows aggregation, which is the opposite process. A group of separate hosts can be tied together and represented to the guest as a single host. This function is naturally implemented in middleware for distributed computing, with a classical example represented by a cluster management software which harnesses the physical resources of a homogeneous group of machines and represents them as a single resource. Next one is emulation. Guest programs are executed with an environment that is controlled by the virtualization layer, which is ultimately a program. This allows for controlling and tuning the environment that is exposed by the guest. For instance, a completely different environment with respect to the host can be emulated, thus allowing the execution of a guest programs requiring specific characteristics that are not present in a physical host. Last one we have is isolation. Virtualization allows providing guests, whether they are operating systems, applications, or other entities, with a completely separate environment in which they are executed. A guest program performs its activity by interacting with its abstraction layer, which allows which provides access to the underlying resources. Isolation brings several benefits. For example, it allows multiple guests to run on the same system without interfering with each other. Second, it provides a separation between the host and the guest. The virtual machine can filter the activity of the guest and prevent harmful operations against the host. Next one, we have portability. The concept of portability applies in different ways according to the specific type of virtualization considered. In case of hardware virtualization solution, the guest is packed into virtual image that in most cases can be safely moved and executed on top of different virtual machines. Except for the file size, this happens with the same simplicity with which we can display a picture image in different computers. Virtual images are generally proprietary formats that require specific virtual machine manager to be executed. In case of programming level virtualization as implemented by JVM, that is Java Virtual Machine, or .NET Runtime, the binary code representing the application components such as jars or assemblies can be run without any recompilation on any implementation of corresponding virtual machine. This makes an application development cycle more flexible and application deployment very straightforward. One version of application in most cases is able to run on different platforms with no changes. Finally, portability allows having your own system always with you and ready to use as long as the required virtual machine manager is available. This means that once you create a virtual machine using the hypervisor software on any system, you can carry that system or that virtual machine wherever you want. That can be implemented or installed, not completely, but just plug and play kind of thing, and can be used on any different systems. This is what generally is being done in most of the labs. That's all for today. Thank you.